Braking is a basic driving skill. It often indicates the difference between an experienced driver and a novice. When the driver slams on his brakes on a wet or icy road, look out. Under such conditions, it is easy to slip, and sometimes the car may slip sideways. Sudden application of the brakes causes the wheels to lock and slip. The car not only continues to move, but there is a loss of direction and steering control. When good drivers are faced with such a situation, they will apply brake pressure gradually and maintain steering control. Under the same conditions shown before, this car stops without slipping. This is because this car is fitted with an ABS, that is, an anti-lock brake system. This system produces effective braking through computer control of the hydraulic pressure of the brakes. In other words, the ABS is a system for maintaining directional and steering control by preventing the wheels from locking when the brakes are slammed on. The ABS duplicates the effective braking of the good driver by using a computer to control the braking. The ABS has the following components. Both front wheels are fitted with front speed sensors to detect the speed of the front wheels. There are rear speed sensors for the rear wheels. One is fitted to each rear wheel. The stoplight switch detects braking conditions. This is the heart of the system, the ABS computer. The computer receives wheel speed signals from each speed sensor, and by means of a signal from the stoplight switch, which detects the speed of the wheels at the time of braking, it sizes up road conditions and sends signals which put the actuator into operation. The actuator controls the hydraulic pressure in the disc brake cylinders of each wheel by signals from the computer. The warning light comes on when something is malfunctioning in the electrical system. This warning light can also be used for diagnosing the ABS system. We have just described the component layout for the front-wheel drive Celica. In the four-wheel drive Celica shown here, the computer and actuator are under the rear seat. In this model, there is a deceleration sensor at the rear side of the computer. Now, we will take a look at the actual construction of the system and see how it works. Each steering knuckle is provided with a speed sensor, and each axle hub is provided with a serrated rotor. The speed sensor consists of a permanent magnet and a coil. As the serrated rotor revolves, the amount of magnetic flux produced by the permanent magnet fluctuates, causing an alternating electric current in the coil. The frequency of this alternating current is in proportion to the rotational speed of the axle hub. So with this arrangement, it is possible to sense the speed of each wheel. Each rear speed sensor is fixed to a parking brake plate, and a serrated rotor is provided on each rear axle hub. This is the deceleration sensor used on four-wheel drive vehicles. Unlike the front-wheel drive vehicle on which the rear wheels are not driven, the four-wheel drive vehicle has special characteristics during braking because all four wheels are being driven. For this reason, a deceleration sensor is provided to detect vehicle deceleration. Inside the deceleration sensor are two light-emitting diodes, or LED, on one side, and two phototransistors facing them on the other side. A pendulum is situated between the LED and phototransistors. The plate of the pendulum has slits and is called a slit plate. This slit plate swings at the time of braking, and the amount of the swing causes the phototransistors to switch on or off. Thus, the deceleration sensor detects the drop in vehicle speed during braking and sends this information to the ABS computer. In this way, signals from the speed sensors and deceleration sensor help the computer to make a more accurate appraisal of road conditions. This is the ABS computer. It performs the following functions. First, its basic function is to control the wheel speed according to the road conditions. An initial check function enables the actuator to check out its own electrical system. A further function is the diagnosis of malfunctions. Finally, there is what is called a fail-safe function, which assures no more braking function if some failure occurs in the signaling system to the computer. The actuator reduces or increases the fluid pressure in the disc brake cylinders according to signals from the computer. In this way, it controls the speed of the wheels. The actuator is composed of the following components. 1. Three-position solenoid valves, which change the mode of brake fluid pressure by holding, reducing, or increasing the pressure in the disc brake cylinder. And 2. A pressure reduction unit consisting of a reservoir for brake fluid returning from the disc brake cylinder, and a pump for returning the fluid in the reservoir to the master cylinder. Incidentally, the pump is driven by a motor and revolves continuously while the ABS is operating. As an example, let's take a look at the operation of the brake system of one front wheel. Under normal braking conditions, when slip between the tire and the road is rare, the anti-lock brake system does not operate. In this situation, the three-position solenoid valve does not operate. Port A remains open and port B remains closed. Brake fluid pressure is applied to the disc brake cylinder through port C. When the brake pedal is released, the brake fluid returns to the master cylinder from port C through port A and number 3 check valve, so that no fluid pressure remains in the disc brake cylinder. However, when slip between the tire and road increases greatly, a signal from the ABS computer causes the three-position solenoid to operate. Let's see how the reducing, holding, and increasing modes of the three-position solenoid valve operate. First, the holding mode. When the three-position solenoid coil receives about 2 amperes of electric current, the solenoid valve moves to the central position. At this time, port A closes and cuts off the fluid pressure from the master cylinder. At the same time, even though the pump motor is turning, there is no drop in pressure because port B is also closed. In this way, the pressure in the disc brake cylinder is kept the same. Next, the pressure reduction mode. When the three-position solenoid coil receives about 5 amperes of electric current, the solenoid valve moves to the position shown here. At this time, port A is closed, cutting off fluid pressure from the master cylinder. At the same time, port B is open, and the disc brake cylinder fluid is sent to the reservoir through port C. The pump motor operates on a signal from the computer so that the fluid stored in the reservoir is returned to the master cylinder. This results in a drop in disc brake cylinder hydraulic pressure. Finally, the pressure increase mode. We will look at the pressure increase mode when the fluid pressure of the disc brake cylinder is lower than the fluid pressure of the master cylinder. As no current is flowing in the three-position solenoid coil, the return spring pushes the solenoid valve back to the position shown here. This causes port A to open, and fluid pressure from the master cylinder is applied to the disc brake cylinder. With port B closed and unable to affect the pressure, the fluid pressure at the disc brake cylinder increases. This graph shows the connection between vehicle speed and the speed of one wheel, and also the change in fluid pressure in the disc brake cylinder of that wheel when the ABS is operating. When the speed of the wheel drops quickly due to sudden application of the brake, the ABS computer starts the actuator and reduces the fluid pressure in the disc brake cylinder. Then, as the speed of the wheel increases, brief switches between holding and increasing modes increases the fluid pressure of the disc brake cylinder a little at a time. By controlling the speed of the wheel in this way, wheel lock is prevented. Switching from one mode to another many times in a very short time allows the car to slow down without the wheels locking. The anti-lock braking system uses a 3-channel control method by controlling the front, left, and right wheels independently and the rear wheels together. Next, let's take a look at the service points of the anti-lock brake system. The ABS computer has the following functions. When the vehicle is traveling at more than 6 kilometers per hour and the stop lamp switch is off, the initial check function activates the 4 three-position solenoids and pump motor in turn in a self-diagnosis. During this initial check, you will hear the sound of the actuator motor, but this is quite normal. When there is a malfunction in the electrical circuit of the ABS, the computer, which has a fail-safe function, will stop sending control signals to the actuator. In this condition, the ABS will not operate, but the normal braking system still functions. When something goes wrong in the electrical circuit of the ABS, the anti-lock warning light in the combination meter will light up to inform the driver about it. To check into this, disconnect the check connector and turn the ignition switch on. When this is done, the anti-lock warning light will begin to blink. The number of times that the warning light comes on will give you the code number. Let us now observe an actual lamp blinking pattern. This lamp is blinking at regular intervals. This indicates that everything is normal. The blinking of this lamp is different from what we just saw, isn't it? It means that there is a problem somewhere. The number of times that the lamp blinks every half second after a 4-second pause indicates the first digit of the code. The number of blinks every half second after a 1.5 second pause indicates the second digit of the code. In this case, the lamp blinked 3 times, then twice, so the blinking pattern indicates code number 32. Should there be a malfunction in more than one place, the indication of code numbers will start with the smallest code number. When this happens, indication of the second code number will begin after a pause of 2.5 seconds. This warning light blinking pattern will be repeated continuously. After the diagnosed defects have been rectified, the diagnosis memory in the computer must be cleared. This is done by 1. Stopping the vehicle, 2. Disconnecting the check connector, and 3. Depressing the brake pedal 8 times or more in 3 seconds. This will eliminate the code numbers from the memory. Then, 4. Check that the warning light shows the normal code. And 5. Connect the check connector. Besides the function of checking for malfunctions in the speed sensors and rotors, the computer also has a function for checking the efficiency of the sensors. This is provided exclusively for servicing and must be handled in a special way. First, let's consider what to do on a front-wheel drive vehicle. Step 1. Turn the ignition switch on and check that the warning light goes off after coming on. Step 2. Turn the ignition switch off and disconnect the check connectors. Step 3. Next, turn on the engine and the warning light will begin to blink. Step 4. In this condition, depress the brake pedal exactly 5 times in 2 seconds. When this operation is performed, the warning light will begin to blink quickly. The blinking speed will be twice that of the diagnostic code indicating normal. In this way, the speed sensor check mode is set. Afterwards, if any of the following operations are performed, the speed sensor check mode will be cancelled. 1. The ignition switch is turned off. 2. The parking brake switch is turned from off back to on. 3. The brake light switch is allowed to come on 16 times or more. A road check is made without cancelling the speed sensor check mode. 1. Release the parking brake and drive the car forward normally at between 4 and 6 kilometers per hour. When the speed reaches 4 kilometers per hour, the warning light, which was blinking, should go out and then come on again after 1 second. This ends the sensor output voltage level check. At 6 kilometers per hour or more, the warning light will begin blinking again. This indicates that there was nothing wrong during the output voltage level check that has just been performed. 2. Next, drive the car straight ahead normally at between 45 and 55 kilometers per hour. At this speed, the warning light should go out and then come on after 1 second. This ends the sensor output voltage fluctuation check. When the car leaves the range of between 45 and 55 kilometers per hour, the warning light will once again begin to blink. This indicates that there was nothing wrong at the time of the output voltage fluctuation check. During this road check, when the warning light is out for 1 second, the computer diagnoses each of the speed sensors. so be careful not to handle the clutch roughly or suddenly accelerate at this moment, as this will adversely affect the diagnosis. If there is a malfunction, the warning light will come on and stay on. Three, stop the car and check the blinking of the warning light. At this time, by switching the ignition switch off or switching the parking brake switch on, the results of the speed sensor check will disappear from the memory, and the normal diagnostic code should be indicated. When something is wrong, decipher the code number by the blinking pattern. For example, if the light blinks 7 times at intervals of half a second, and then lights up twice after 1.5 seconds, the code number is 72. After 4 seconds, that same code number will be repeated. With this, all diagnosis of speed sensors is finished. Now you can reconnect the check connector. Next, let's see what is done in the case of a 4-wheel drive vehicle. Step 1. Turn the ignition switch on and check that the warning light goes off after 3 seconds. Step 2. Turn the ignition switch off. So far, this is the same as the front-wheel drive, isn't it? Step 3. Short the TS connector in the engine compartment. Step 4. Next, do not depress the brake pedal, but pull on the parking brake instead and start the engine. Check that the warning light is blinking. With this, the mode for the speed sensor check has been set. As with the front-wheel drive vehicle, we now do a road check in this condition. This road check is performed exactly as with the front-wheel drive vehicle to let the computer make the diagnosis. Check the output voltage level at between 4 and 6 kilometers per hour, and the output voltage fluctuation at between 45 and 55 kilometers per hour. If there is a malfunction, the warning light will come on and stay on. Stop the vehicle. Disconnect the check connector. And check the blinking of the warning light. For example, this code number 74 indicates, as you see here, that there is too much clearance between the rotor and speed sensor of the left rear wheel. When the diagnosis is finished, connect the check connector and remove the shorting pin from the TS connector and install the cap. With this, the malfunction code will be cleared from the memory. There is a deceleration sensor on the 4-wheel drive vehicle for detecting a drop in vehicle speed. Let's see how this deceleration sensor is checked. Step 1. First, switch on the ignition and check that the warning light goes off after 3 seconds. Step 2. Turn the ignition switch off. Step 3. Short the TS connector in the engine compartment. Step 4. Pull the parking brake on and start the engine with the brake pedal depressed. If there is one blink every second, the deceleration test can be performed. First, a road test is performed to check whether or not the deceleration sensor is operating. 1. Drive the car at about 10 kilometers per hour and then lightly apply the brakes. Check that the warning light remains blinking. 2. At around 20 kilometers per hour, apply the brake a little more strongly. Check that the warning light is only on during braking. After brake is released, the warning light re-blinks. 3. At the same speed, apply the brake strongly. The warning light will change to fast blinking. We have confirmed that the deceleration sensor is functioning properly. Next, let's check the angle at which the deceleration sensor has been installed. 1. Make sure that the vehicle is on a level floor and slowly jack up the rear to the height specified in the repair manual. Check that there is no change in the blinking of the warning light. 2. Gently jack down the rear end and check that there is no change in the blinking of the warning light. 3. Repeat this procedure for the front of the vehicle. If there is still no change in the blinking of the warning light, then the deceleration sensor is functioning properly. If there is a malfunction in the deceleration sensor, the pattern of the warning light will change. This finishes the deceleration sensor check. Remove the short pins from the TS connector. During servicing work, be careful not to damage the ABS, computer, speed sensors, serrated rotors, or deceleration sensor. To check the functioning of the actuator, an actuator checker and sub-wire harnesses are used. But the actuator checker cannot be used to check all of the ABS system. In the case of a front-wheel drive vehicle, this checker is put into position in the following way. 1. First, the short sub-wire harness is connected to the actuator checker, and the long sub-wire harness is connected to the short sub-wire harness. 2. Next, the connectors connected to the actuator are disconnected. 3. Then the connectors of the short sub-wire harness are connected to the connectors of the actuator and engine wire harness, and the ground cable is connected to the body. Next, the connector connected to the control relay is disconnected, and the connector of the long sub-wire harness is connected to the control relay. 4. Don't forget to connect the power supply cables of the actuator checker to the battery terminals. 5. Finally, sheet A, on which the layout of switches is written, is placed on top of the actuator checker. In this case of a four-wheel drive vehicle, the long sub-wire harness is not used. 1. All 3 connectors connected to the actuator situated under the back of the rear seat are disconnected. 2. The connectors of the actuator checker are now connected to the actuator. After this, it is the same as for a front-wheel drive vehicle. 3. The power supply cables of the actuator checker to the battery terminals. 4. Sheet A, on which the operation is outlined, is placed on the actuator checker. Everything is ready, so let's start the actual check. 1. First start the engine and let it idle. 2. Set the selector switch for the disc brake cylinder being checked. 3. Press the motor switch for a few seconds. 4. Press the power switch while keeping the brake pedal depressed with a steady amount of pressure. It should not be possible to depress the brake pedal any further. Do not press the power switch for more than 10 seconds. 5. Release the power switch and see if the brake pedal can be depressed any farther. 6. When the motor switch is pressed, the pedal returns. 7. Now release the brake pedal. 8. With the brake pedal released, press the motor switch for a few seconds. 9. Next, while keeping the brake pedal depressed with a steady amount of pressure for about 15 seconds, press the motor switch and check whether or not there is pulsation in the brake pedal. Repeat these checks for the other disc brake cylinders. When the check is finished, remove the checker and reconnect all the connectors of the ABS, actuator, and control relay. When the actuator and relay connectors were disconnected, trouble in the solenoid relay was recorded in the memory of the computer, so the memory must now be cleared. Air blading on the ABS is performed in the same way as conventional brake systems, by bleeding the air from the actuator and brake lines. Also, as it is not possible to disassemble the ABS actuator, the actuator assembly must be replaced if some malfunction is found. While the anti-lock system is functioning normally, the brake pedal may pulsate, and the vehicle body and steering wheel may vibrate. Do not take risks. Because you have an anti-lock brake system, you must still keep a safe distance from the car in front of you. In fact, the braking distance of the anti-lock brake system may be longer than that of conventional brake systems. Always reduce speed when cornering and when roads are rough or covered with snow or gravel. The anti-lock brake system is a new mechanism that will be used more and more in the future to improve braking efficiency and maintain driving stability. We hope that you now understand what this anti-lock braking system is all about. We would like to take this opportunity to encourage you to become even more familiar with this system by thoroughly studying the service training information, new car features, and repair manuals.